the launching pad, and here's the racket, and here's the angle of elevation. So let me explain that. Again, forgive me, I cannot draw a person. I'm not capable. So if this is a person and here's a wall, this, let's say I want to look up to the ceiling, this angle is angle of elevation. Angle of this angle, if I want to look at the base of the wall, this angle is called angle of depression. Okay, angle. So this is the angle of elevation going up, depression going down. Okay. The angle of elevation, okay, is the correct rate? Yes, to keep the racket inside. Also, the mechanism for focusing the camera has to take into account the increasing distance from the camera to the rising racket. Let's assume the racket rises vertically and its speed is, I think I read 600 or 500, I'm not sure, it's in red. Is it 600 feet per second or 500? 600, okay. So if this is y, then I know that dy over dt equals 600 feet per second. When it has risen 3,000 feet. Okay, so this is when y equals 3,000. How fast in feet per second is the distance from the is it whatever on camera to the racket changing at that moment? Okay, so I'm going to call this W, and we have W squared equals Y squared plus 4,000 squared. And then we have, we differentiate implicitly, and we get 2W dW over dt equals 2Y dy over dt. And then I get that dW over dt equals y over w dy over dt. So at that instant, this is 3,000. W, I don't know, I have to determine it, is the square root of 3,000 squared plus 4,000 squared. And dy over dt is 600. I just want to make sure that everything is in feet and there is no trick here. Okay, so then dw over dt, my calculator, is, so 3,000 times 600, I shouldn't do that with the calculator. It's embarrassing. Okay, the square root of, in parentheses, 3,000 squared plus 4,000 squared, close the parenthesis, outside, enter, 360. So 360 is in feet per second. Part B. If the televisor camera is always kept the racket aimed at the racket, okay. How fast in radians per second is the camera angle of elevation changing at that moment? Okay, perfect. So in this case, we have, which page am I on? 13. So in this case, in part B, so this is part A, and then part B, we're asked to find d theta over dt, and we have I'm going to use sine. So sine theta equals y divided by w. No, I'm going to use tangent, which is y divided by 4,000. C, secant squared theta times d theta over dt equals 1 over 4,000 dy over dt. So finally, d theta over dt equals 1 over 4,000 times dy over dt divided by secant squared theta. Okay. This I have. It's given to us as 600. This I don't have because I don't have theta. But when y is 3,000, then secant, so secant is 1 over cosine, but I have to involve w. I have no choice. So if this is 3,000 and this is 4,000, and this should be 5,000. Because these are Pythagorean numbers, but let me double check. Because 3, 4, and 5 is correct, but I haven't checked. It may not be. So I have square root of 3,000 squared plus 4,000 squared. Yeah, just making sure. Okay, so if that's the case, then secant is 5,000 over 4,000, so 5/4. Okay, so from here I have d theta over dt, 1 over 4,000 times 600. And secant again, cosine is 4,000 over 5,000 or 4/5, but secant is 5/4, but squared. Okay. So I have 6 at the top. So I have 6 divided by 40 and divide by, in parentheses, 5 divided by 4 squared. And I got 0.096 radians per second. And this is d theta over dt. Very interesting problem also. Quite nice.